Morning, everybody. Today we're going to discuss about geotechnical engineering on what we did in project number 2. This of project number is 284 EPD, and we'll talk about geotechnical engineering. Geotechnical engineering. Our plan lies into many important parts. The first one we'll discuss on soil mechanics. Soil mechanics. The second one will deal with standard panometric test, and then the third one deal with pressure meter test. And the first thing to know is that the project itself, you have to get the plan of the project, will have the same project as last time we saw it last time, coming that side and then going down. We have done the geometer test 1 here, and then here we done standard panometric test 1 here, standard panometric test 2 here, standard panometric test 3 this side, and then standard panometric test that side. Now what are we going to talk? First thing is to move to the soil mechanics. Okay, let's start with the soil mechanics. First thing. Now, talking in terms of soil mechanics, what are we going to talk about? You should first of all know about, let's take a soil sample, because you get a sample of soil, which is something like that, like this, having this is a soil sample. Now we have to move from that step to soil phases. Now you get something like that, like this one. This is here solids, and then water, and then air. You assume that you get a volume of air, volume of water, and then volume of solid, and then which is you can also say you get the volume of voice and then the volume of solid to get what they call the total volume. Very important. When you reach at that level, I have to say something before moving forward. First, when you are undergoing a geotechnical investigation, you must have at the end to be able to get the material identification. Secondly, to get the bearing capacity of the soil for it to be able to face or to meet the construction load, and then you also have what they call the depth of the substratum depth. Okay, you cannot conclude in a geotechnical report without passing through these 3 phases. The first one is in the geotechnical soil mechanics. And then we'll talk about 2 important things. The first thing is the size of material, the material size, according to get the clay and so on. Okay, or gravel, sand, according to the dimension of each material. Okay, for sand, you know that when you lie between 2 to sand, you are not more than the sand. Okay, we lie between 5 to 15 or to 15 to 15. You are now dealing with gravel. You should be clear on that. This will be very clear. But the most important type is what they are calling the volume ratio. Let's talk about the volume ratio now. The volume ratio, that is, you should know that volume ratio deals with 2 parameters important. That is the volume or the volume of void, which label E equal to volume of void all over volume of solids. Okay. Now you have porosity, which is N, which is equal to the volume of voice all over the total volume. Now, how are you going to get the volume ratio now to be able to identify the type of material that you have? First thing you should know, let's write porosity in terms of the voice volume, or you can also write voice volume in terms of porosity. Okay, what I'm going to take, first thing, we know that let's say equation 1, equation 2, okay? According to 2 is the same thing like N equal to the volume of voice all over the total volume, which is equal to the volume of voice all over the volume of voice plus volume of solid, referring to this soil faces. Okay, this is soil faces. You can show that you can read that the volume of voice is equal to the volume of air plus the volume of water. That is what they call the volume of voice. And then adding to the volume of solid, you get the total volume. That's why when you have porosity, which is equal to the volume of voice all over the total volume, is equal to the volume of voice all over the volume of voice plus the volume of solid. Now, referring to equation number 1, where E equal to the volume of voice all over the volume of solids, that is, the volume of solid will be equal to the volume of voice all over E. Okay, now from this one, we'll be able to write N now will be equal to the volume of voice all over the volume of voice plus the volume of voice all over E. I see what I'm doing, which is now equal to, which is the last in between, which is the same thing like writing volume of voice, all over the E volume of voice plus the volume of voice all over E, which is equal to, we give you, volume of voice all over 1, and then E, yes, E here, and E, the volume of voice plus the volume of voice. I can step it from 1. We now equal to what? Let's start now at, you see you have a volume of voice here, volume of voice here, which is the simple like writing volume of voice all over 1 here, and you have E here all over the volume of voice factor E plus 1. And then you simplify E here, and you will get now, this is E all over E plus 1. We are now done with it, saying that porosity can be written by saying E equal to the N, porosity N equal to the volume of voice over the volume of 1 plus 1. First thing done. And call it equation number 3. Now you can move backward, knowing that from this one, from equation 3 now, you can say that the volume of voice plus 1 factor E, factor N will be equal to the volume of voice, which is the same. This is the same idea that is exactly equivalent to volume of voice porosity plus porosity equal to E. Now you got to remove now E, move E the same side and the other one the other side. Then we have the En minus E will be equal to minus N, which is exactly we imply that E is a factor N minus 1 is equal to minus 1. We imply that E will be equal to minus 1 all over N minus 1, and then that is the same thing like writing E equal to N all over 1 minus 1 minus N, and you are done. Okay, question number 5. This shows that the relationship between the volume of voice and the porosity, very important. Second point now, the standard pneumatic test. On the site, we observed that we went to standard 1, 2, 3, 4, and then that's 4. we went to the deep, we zoomed down, we get to the deep of, more than a deep less or equal to 10 meters, and we only have like, uh, how do you call it? Yes, the bearing capacity will be 2.1 bar. But when you move to the third one, that is, listen very well, pressure metric test, that we call it PMT, we go down to the deep of 15 meters, and we only have bearing capacity equal to 0.7477 bar. So we can decide it on many type of foundation. Shadow foundation, if you take shadow foundation, you only have, isolated footing, or mat footing. That is a deep of less than or equal to 3 meters. 3 meters. You can also change and move to pillars, pier footing, to move down 10 or 15 meters, 10 or 15 meters. And the laboratory gives us the ratio to be taken as a 1.1 bar or 1.15 bar, 1.15 bar. And then we are done. So finally, you should know that the geotechnical investigation help us to determine the bearing capacity of our soil, firstly. Secondly, to determine the substratum deep of our soil. In these particular cases, or in this particular case, we lies at 3 meters, can move to shallow foundation at 3 meters. Now you have two choices. The first one, you can use isolated footing or mat footing. Mat footing means this large standard we just call putting called a reinforced concrete, okay? But isolated footing is the pillars down, and at the end you have a footing. There are another choice that we added, because you can, according to the, how you call it, the pressure meters test, we discovered that right up to 15 meters deep, we are not yet having sand, even though the laboratory tells us we have sand. We never had sand right up to 15 meters deep. So we can also move and choose deep foundation, that is pillars on the pillars footing, even though it might be a little bit more expensive and necessary, and require more skills professional to execute it. And that end our lesson on the foundation. Thank you so much. Let me send it back in French for those who don't understand English, because it's kind of easy, even though we are a bilingual area and Commonwealth area. But I try to explain. Let me say it in French. Les études géotechniques ont pour objectif de déterminer, ce que je viens d'expliquer en anglais, la résistance ou encore la contrainte admissible du sol, la profondeur du substratum et le type de fondation à adopter par rapport au poids de la construction et à la dimension de l'emprise du bâtiment. C'est très important. Pour le faire, un laboratoire sérieux devrait passer par 3 tests minimum. Le premier, c'est l'analyse granulométrique, qui permet de déterminer les différentes dimensions des différentes graines afin de dire spécifiquement quel est le type de sol ou quelle est la classification des sols traversés. C'est-à-dire, on peut avoir, bien sûr, comme on a souvent vu le cas, de la terre végétale, ensuite de l'argile, pourquoi pas du sable argilo-sableux. Ça dépend des dimensions des grains, ce que beaucoup ne font pas. C'est ce qu'on appelle l'analyse granulométrique. Deuxième test à faire, c'est l'essai pénométrique, qui permet, au moyen d'une tige, de plusieurs tiges d'un mouton avec un guide, de battre dessus le nombre de coups, déterminer à quelle profondeur et à quelle est la résistance selon les différents puits. Et dans le cas d'espèce, nous avons participé, nous avons fait 4 points pénométriques, le point 1 juste là derrière, le deuxième là, le troisième et le quatrième. Dans le rapport que nous avons reçu, ils ont inversé ces points comme c'était du copier-coller. On ne sait pas trop bien ce qui s'est passé, mais on rappelle, ils doivent procéder à la correction, que le point 1 c'était bien là, le point 2 ici derrière, le point 3, le point 4. Et nous avons fait un seul point pressiométrique qui se trouvait entre le point 4 et le point 3. C'est très important. Nous exigeons que la correction soit apportée très rapidement. Donc, à partir, je t'en dire, à partir donc des études du test, je vais dire, pénométrique, on s'est aperçu que jusqu'à la profondeur de 10 mètres de profondeur, on avait une résistance comprise autour de 2,1 bar, ce qui n'était pas très mal. Par contre, le pressiomètre, lui, c'est-à-dire un peu plus précis parce que nous sommes allés jusqu'à 15 mètres de profondeur et quand on prend la pluie, l'instance était très variable, on était à 0,57 bar, tout ce que nous avons trouvé, 0,57 bar. Le laboratoire propose qu'on prenne une barre, 1,11 bar, 1,15 bar selon qu'on va travailler en ELS ou en ELU. Mais nous, ils ont proposé deux types de fondations. Une fondation en semelle isolée, une autre sur radier. Nous ajoutons une troisième alternative qui peut être sur la fondation en puits ou en pied qui peut aller au-delà, bien sûr, de 15 mètres ou au moins à 15 mètres parce que justement, contrairement à ce qu'on a vu dans le rapport, nous n'avons pas trouvé de couche sableuse. Non, c'est de l'argile pure et simple que nous avons trouvé. De l'argile pure et simple jusqu'à 15 mètres de profondeur et il faut dire que le pressiomètre qu'ils ont utilisé s'arrêtait à 15 mètres, pourtant on peut aller aussi au-delà avec des engins plus importants, mais ça va coûter beaucoup plus cher encore. Jusqu'à 15 mètres, on n'avait que de l'argile, ce qui est un peu inquiétant. Ça veut dire que là, nous allons maintenant avec nos ingénieurs structures essayer d'étudier le type de fondation qu'il faudra choisir entre, bien sûr, soit les fondations en semelle isolée ou encore la fondation sur radier, ce qu'on appelle fondation presque superficielle, ou encore une fondation semi-profonde sur puits qui savait être le meilleur choix possible. Donc voilà un peu terminé ce qu'on avait à dire sur les essais géotechniques et nous pensons que le message est assez bien clair pour eux, pour tout un chacun. Merci.